Hello and good morning from Berlin. It's sunny and tomorrow morning it was -6, so all is great. Welcome to our next webinar, which is with a focus on technology. As the attendants who have visited previous webinars know, there is a survey at the end of this webinar, which I very much urge to fill in. We did one after yesterday's edition, and as it always is, some were happy with the tech level, others found it too much tech, others didn't find it enough tech. So for the attendants who find it not enough tech, there'll be a homework which will be very technical, so we can join later in live prompting. For the ones for whom it is too technical, I very much invite you to visit previous webinars, because many of the terms and concepts that I use have been explained before. So that's an invitation to visit our website, our previous webinars, and of course an invitation to visit our next webinar, which will be really focused 100% on creating prompts to solve problems. Why we are doing this particular webinar? So there are two things. The one thing is, as I said in the beginning of the last webinar, we think that search is dead. Not really dead, of course, and I'm aware that this is a little bit noisy, but at least for the people younger than 25, ChatGPT and others have substituted Google. And of course, this research behavior or search behavior will translate into more general use of GPTs in the future. So we assume that the way you're looking for content and the way what you expect in terms of answers, the future will be AI. So that's the first thing. And of course, the sooner you get into the world of AI, the better you are prepared to follow or even lead this big shift in accessing content. The second reason is, of course, we have now running the chatbot for the Berlin library since June last year. We have already a number of test cases running with various libraries across Europe. Also, by the way, in Serbian, so we can also deal with Cyrillic writing and a mix of languages and writings. But one thing that I regularly encounter with in talks about AI is that there are expectations that are kind of a mixture between, you want something that can do all and is pretty much like search, but better. That is not true. So the thing is, search can do many things that AI can't, and the other way around. So the search cannot answer based upon emotions. So I cannot tell the search slit of the library website, I'm bored, can you recommend me something, but I'm really tired, don't let it be light. So a search will not be able to answer that. Also, the search will not ask back, what do you mean by that? Do you want an e-journal or do you want a book? A search certainly cannot do that. And I think most importantly, a search, the prerequisite of a search is that you already know what you want to do, what you are searching for. So this kind of library experience that I really cherish, that you stand in front of a big board of books and kind of browse through it and let yourself be inspired. Like, for example, for films on Netflix, where you just browse through and you don't really know, but then you find something that you're interested in. The search certainly cannot do that, but AI can. But of course, AI is not perfect. So there are a lot of things that AI cannot do, or there are a lot of things where you have to make trade-offs between various components of AI. And to understand these limitations, or the current limitations, because of course it's developing very quickly, is really the topic of this webinar. So with this short intro, I'm going to start. So this is me. It's boring. You can read that. Just the only change to last webinar is that I call myself now lecturer on AI, because I did some official courses, and as you might realize in this webinar, I really like teaching and telling about AI. But I'm still the same person. This is important because these are integrations we already have with different library management system. Axial, the Tronic is German. Koha, you're probably all familiar with. Aztec is the Berlin one. The most important piece of that information is that once you're part of a library management system that we have an integration for, the setup is first of all a question of minutes, and the second, it doesn't cost from our side, it doesn't cost anything. So if you want to test us, and if you have a library management system that is not on this board, contact them. We'll get involved. So also before I go into more depth, I want to talk a little bit about terminology because the bots in an AI-Chatbot for libraries can do quite many things, and these many things have different setups, different requirements, different target groups, and different challenges. So let me tell a bit about what I mean by that. So a recommendation bot, as you all know, is something where the bot tells you, oh, okay, you're searching for a travel guide to, I don't know, Trinidad and Tobago. By the way, very big surprise for me is that so many participants come from Trinidad and Tobago. I really like that. Anyway, so you have a travel guide for Trinidad and Tobago, and I can recommend it to you. So this is a recommendation bot. Actually, the issues of a recommendation bot are mostly the probability engine that an AI is, or a similarity search. We'll come to that. On the other hand, for example, the service bot is the bot that answers questions about organizational things like library opening hours, what happens if I lose a book, where's the cafe, you know, like the really important things that the men and women at the desk answer every day. So they have different sources of data that needs to be imported to answer these questions. And also, if a recommendation goes wrong, that might even be an inspiration. But if the opening hours are different, you might stand in front of a closed library at -11 in Berlin, and that is painful. So different requirements and precision and timeliness of information. A knowledge bot is what we use actually already for internal purposes in any kind of institution. So this is about, for example, where do I apply for a holiday? Or if, for example, I have a problem with a colleague, who can I call? What was the last press release on this and that? So this is an internal knowledge management tool, which, especially if you think about onboarding new people, that happens regularly, but nobody ever has time for. It helps quite a lot. Here, of course, data protection is way more important than, for example, if you just recommend some books to an unknown person. And of course, the data sources are very different. So you can have typo 3, you can have PDFs, you can have wikis, and you need to kind of pull all of that together to get good results. And the last one is the media bot for the universities. Among you, there are also very many universities on board this webinar. This is like Scopus AI, but for your library content. So this is, you don't talk about content, but you talk with the content. So you actually can really talk with a book and get and also get the quotations of where the with which data a specific answer was created. So you can actually continue researching after you got the answer up by the bot. So these are kind of the different for us. So this is not an official terminology, but for us, these are the different use cases that typically come up in a library context. And so when I talk about that and the different trade-offs and challenges, please remember what I'm talking about. So also this one, I mean, it has been updated over the last months, but this is kind of the workflow that we're talking about. It's called a RAG workflow. RAG stands for Retrieval Augmented Generation. Frankly, I have no clue what that means. The only thing I understand is retrieval, because this is about how to get the data of your institution into a conversation with a large language model, so with AI. Let me quickly walk through it, because this is really needed to understand how such a chatbot actually works. So you have two parts. You have the black part, called metadata, so the black square, and you have the blue part, which is the conversation. I'll start on the left with here, with which data comes into the bot. So you have, of course, institutions, you have public libraries, university libraries, scientific libraries. Actually, we now work with museums. All these data is sent to us. We also, of course, for us, it's sometimes easier not to work with the library, but to work with a third-party service, so with a library management system, because then we can do this integration work once for many libraries. We also actually scrape information from websites, especially when the service bot is concerned, because many times it's just easier to get information, up-to-date information from websites and not from some hidden internal sources. By the way, gray is what we want to do or what we're working on. Black is what we are already doing, and it's turning more and more black. So you can see our progress here too. So these are the people who deliver us data, and then these data comes in different forms. You have Mark 21, of course, for libraries. You have Dublin Core for museums, HTML if we scrape websites, PDFs. So all the sources of data that are required for the different bots. So we take this data. We have created what we call an importer. It's actually not mentioned specifically on this thing, but it's important because this data typically is structured data, and AI so far doesn't really work well with structured data. So we're turning these structured data into natural language. A very simple example, if the structured data contains, for example, genre thriller, what we do is take this field in the Mark 21 file and basically and create the sentence, the genre of this book is a thriller. So this is what the importer is doing. And then you have a natural language file for this book. This then is chopped off into chunks, because you cannot, for example, the Berlin Libraries has almost 3.5 million different data sets we work with. So you cannot just throw 3.5 million files at the LLM. So you chunk it up. Not only actually, basically these chunks are then what in our backend are then sent to the so-called embedding model. The embedding model, actually, most people think that we're just talking about an AI, but the thing is that twice we use an AI to create things. So the embedding model actually comes first. What does this embedding model do? So what the embedding model does, it takes such a chunk, which is basically a collection of sentences, and turns it into a numerical representation of this chunk. So you have a sentence like this book is about a lonely family in northern Mongolia in 1928. So this is a chunk. And actually, after the embedding model comes back with 1, 2, 3, 7, 5, 6, 7, 3, 5 forever. Actually, we call about dimensions a lot, and so you know 3, maybe 4. The LLM knows about 2000 in our model. So this numerical representation of the data stores a lot, and the most important thing, and this is now the big difference to keyword search, is that it doesn't only store the literal meaning of the words or the sentences. It stores the context as well. So the reason why these vectors are such a large numbers is that not only, for example, you have a cat and a dog, and you have a castle. So in terms of context, the cat, of course, is closer to a dog than it is to a castle. So this kind of meaningfulness is the strength of AI. So you have, and now you have this vector, which is a large number basically, and this is put into a vector database. This vector database is hosted by us. We are running it. So first of all the information generated in this metadata process is sitting actually on a big physical server here in Germany. Full stop. So now we have all the data vectorized or embedded in a vector database. That's it. So this is how the metadata is prepared for the use by AI. Now we move to a conversation. You all have probably used ChatGPT. What now happens is actually the same that happens with every single AI model around the world. You have a user, helpless, wants to know something. The user turns to a bot and asks a question. This question could be anything. It could actually be a text, which is what we do, but it could also be an audio file, which we actually do for a museum, an image, whatever. The bot then sends this question to exactly the same embedding model that we use to create these vectors, and creates another vector. And the vector then is the numerical representation of the question of the user. So now you have two vectors. You have the vector of the user, and you have all the 3 million whatever vectors. It's actually more because the chunks are smaller than the data sets. So the millions of vectors in the vector database. And what we actually do is to do a search in the vector database, which vectors are most similar to the vector of the user. So basically, you make a match here. And what we do is then we take the 30 closest matches, the most similar matches to this vector. This is why it's called similarity search. And these 30 vectors are then again sent to ChatGPT in our case, but it could be anything. We can exchange it also if required. And out of these 30, the LLM chooses the 5 it considers to be the most appropriate. And it then checks the prompts. So the prompts are nothing else than commands that tell the LLM how to behave. And then following these commands, it sends the 5 results to the bot. And the bot basically gives the user the answer. And this circle, bot, embedding model, similarity search in the vector database, context to the LLM, looking for the prompts, sending in the bot, basically is done over and over with each and every question or prompt by the user. So if you have, for example, a conversation that consists out of, 10 question and answer pairs, this circle will be done 10 times. Why that is important, I'll come to a bit later, because it has cost and performance issues, and we have to make a trade-off in there. So this, I know it's a lot. Sorry for the people who see that for the first time. Some of these things have been explained in previous webinars. The overview is important because on some of these issues in this workflow, I'm going to focus in the course of this webinar. All right, so let's continue. One thing I encounter regularly when I do talk about AI is that people say, "Oh yeah, but you are training a model with our data, or so you work with this model and then you get the model you get our data into the model." This is a misconception, and this is plainly wrong. So what we do is in each and every conversation, we hand over the data for this particular conversation to the model. After the conversation is over, the model does know nothing about what it has talked about to us. So you have this image. On the left, we have the RAG model, which is basically the librarian, the guy with the beard, telling the model, which pretty much is highly intelligent, but knows nothing about your data. And in every conversation, we tell the model, okay, this is the information that we're going to talk about. On the right, we have fine-tuning. Then you actually work with the model. You teach the model. So basically, we're handing over the information to the model, and the model then deals with this information for the foreseeable future. The difference is that the right way, that fine-tuning is way more, let's say, resource intensive than just doing a RAG. So we are not doing that. And also, I don't know if it's strategically a good decision now because the models change so quickly and the technology is developing so fast that if you fine tune a model A1 now and in a year, actually the most current model is A3 or A5 already, all your effort on fine tuning is lost. So for the time being, we focus on RAG. So basically telling the model every time we talk with it what it needs to know. So let's start off with, so this is basically the intro. This is kind of the framework that we work in. Let's talk first with the trade-offs. So the first 3 I'm just going to tell you, and the last one I'm going to show you. So the first interesting thing is, which model do you take? So of course, whoever reads the press, there are thousands of models out there, and each is better than the other one. You have Grok of Elon Musk, you have Gemini from Google, and you have OpenAI, of course, with ChatGPT. You have Mistral from France, and there's, all of them. So that's the first thing. So we chose ChatGPT simply because we're working on it since a long time, and also the model itself is not the only thing that is important. The second thing is how do the interfaces work? How easy it is to implement. So actually, the level of intelligence of a model is I wouldn't say secondary, but by now the models have become so good that actually everything around the model is more important than the model itself. So what's the cost structure? How easy it is to implement? How well does it work with our specific use case and stuff like that? So we start with so you really need kind of a good argument to leave a model for another model if you change it. The second thing is, so we're staying with OpenAI for now, but OpenAI also has a lot of models. So you have kind of 4o, you have 4o mini, you have o1, you have o1 mini. So these and we realized that actually the more modern models don't really work for our use case. So in our bots and all of them, we use 4o mini because actually for the stuff that we do, so recommendation bot, service bot, knowledge bot, 4o mini results are pretty much the same as 4o results, and they're even better than these thinking models, which I think were mainly designed for development purposes or for research, but not for the way that we are working with. Also, this is why speed is in there and cost. The more these reflective models, they cost way more, so they're not affordable, and also they're just really slow because they think a lot, and sometimes speed is more important than thinking. In this case, it definitely is, because what is the best recommendation if it takes like 5 minutes to appear on the screen? People will be bored and go away. So for our use case, the most recent models are not the choice that we should make. Second, so this is where you have to look what is really works for your particular use case. The second thing is your controls and data protection. So you want to control the data in some cases. Especially in Europe, we have this data protection thing going on. And but of course, if you, for example, manage internal data with it, so rules or complaints and stuff like that, you want to have this data protected. I mean, for us, all the data for recommendations and service and also for media are sent to probably San Francisco, wherever the servers are, processed and then sent back. If you have more sensible data, you probably want them in your office, but that's actually not a real problem because by now you can put the LLMs on a computer in your office. The problem there is though, and this is why it's a trade-off. I mean, it sounds nice to have your own AI in the office, but there are two things. First of all, you need the people and the personnel who look after it. I mean, this technology is developing very quickly, and also they typically these open models are bad in copyright issues. And what you really don't want is to get a copyright case in your institutions. So actually, this commercial models really have an edge when it comes to copyright protection. So that's also very important for us. And then the next thing is, what do you really want to do with a bot? And so we're talking about, and for our case, with 4 bots. So you have recommendation, you have service questions, maybe you might be even talk to open access books. Do you put all this information, all this conversations into one bot? Or do you break it up to, the service bot in the bottom right of the web page and the recommendation bot next to the search? It's a discussion we have all the time, and we're not sure whether we have found the best solution. It's really up to the users because it's also part of expectation management, right? If you put it in the bottom right, people, like, let's say, more expect service questions than they expect recommendations, for example. Recommendations they would more expect in the area of the web page that is concerned with search. So this is also something you have to think about. Okay, so now a bit of more, let's say, technical stuff, prompting and context. This is very important because this is kind of our daily work. So what are prompting and context? I already said prompting is what we give as commands to the bot, and context is basically the search result that comes bottom right from the vector database as a reaction to the vector that is the user question. So how does that really look? I'll show you. So this is actually the backend. This is our tests bot. And so we have a conversation. This actually is a conversation with all the live FEP data, but of course, this is not, this is a test bot, not the live FEP. FEP is the built-in libraries data. So I'm saying, so it asks me in German, because of course it's a German library, but I can also answer in English. It will answer me in English. Then any other language, you can do Arabic, French, Cyrillic, Japanese should work. So do you have books on how to lead a good webinar? English titles, please. So this is typical conversation. Now the bot starts thinking. By the way, 95% of this thinking time is OpenAI, not us. We analyze that because the thinking is, so okay, now we have here 3 English titles, learning to run webinars, which is actually a very good fit, I think. And now I'll show you what happened in the background of this conversation. So this is the information that has been exchanged with the bot, just for this conversation we've just had. So I'll show you a little bit. So this big column here is the first 30 search results that we received as a result of my question. Then here come, so these here, all this now information about FEP libraries, don't recommend any works by Hitler, for example. Produce Markdown code. This is never use emojis. You know, if you get a very serious work and you get a smiley to it, doesn't really fit always. So this is all the commands that we give to the bot. Commands. This is then the result that is actually sent to me in the bot. And this is actually the content behind these results and some functions calls and stuff like that. So this is a lot of information. So why is this relevant? The relevance is the bigger the context, obviously. So this is the context. And the longer the prompts, the slower the bot becomes, because of course the bot needs to think about all these things. So, and if you see how short this conversation is, and if you remember that whenever you have a conversation, all of this information is put on top of the previous round of conversation, it becomes quite a lot of context that the bot needs to think about. And also, because as you might know, if we exchange information with the LLM, we pay. So in German, because we have very long words, as you might know, every 3/4 of a word is about 1 token in average. So these are many tokens that we exchange with a bot for every conversation. And of course, we have to pay for them. That, by the way, is also the reason why we limit the amount of question and answer pairs. Because, you know, a conversation with a bot, like for somebody who's really bored in the evening and takes like 30 questions and answers because there's nobody to talk to, that becomes expensive for us as well. So we limit it. I think, and then, you know, what's the right limit? In the beginning, we started with 4. But that actually was too little for people to find out. I think in the moment we are with 8. But if there's a limit to the conversation, this amount of context is the reason why it is. All right, so let me return to the presentation. So this is prompting and context. You have to keep the prompt short, but still the bot has to do everything it is supposed to do. And also you have to have the context short. But if you make it too short, then the bot doesn't deliver good answers. So let me show, and then let me show you another aspect of the context. So you've seen the context, so this huge pile of red data that I've just shown to you, and that builds up with every conversation, because with every round we take in this model, the more context we add. Okay, let me again show you how that works. We make a question number 1, sent to the bots. from there to the embedding model. It creates this vector, this numerical representations. It finds 30 search results. This is actually prompted, so we tell the bot to find 30 and not 50 and not 10. And these 30 are then sent to the LLM. And the LLM picks 5. And then it's sent back to the bot. And the bot answers the 5 answers the LLM has chosen. Then I take a second round and I say, okay, so this is a travel guide about Italy, but this is like 2004 version. And what about the most recent version, the 2024 version? So this is the follow-up question. And the follow-up question, again, is sent to the embedding model. It turns into a vector. And now, and this is the key point, this vector is not compared to the whole of the database, but only with the 30 results of the previous question. Why is that? Because you want the LLM to know what the previous conversation was about. So if, for example, if you ask for a travel guide and you say, okay, in the next question, yeah, but I don't want the 2015 version, I want the 2024 version, and the bot doesn't know that you were actually talking about a travel guide in the previous question, it will answer whatever. So you need to remember the context. And the result is that if the LLM in the second round chooses 5 titles, it chooses these 5 titles again out of these 30 results. And the effect might be that 2 or 3 out of these 5 titles might have been part of the previous answer. And that confuses many, that you have results that repeat itself. The reason is here in the context. The reason is that in order to preserve the history of the previous conversation, we limit the context to a certain number. And the second answer is limited to this certain number. Of course, you can say, okay, let's put up the context to 100, and then the probability that the 5 answers are the same is less, but you have seen the amount of data that is then used. It goes exponentially, costing more and hindering efficiency. And so this is, and also, they also decrease in quality. So the first 10 results might have been very good, and the last 10 might have been really beside the point. So this is a very, very important trade-off that you have to keep in mind. And if you wonder why answers repeat, this is the reason, and it's kind of built into the technology. Of course, there are ways to deal with that, but this is one of the issues. So these are the trade-offs. Now come the challenges. So you have, so these bullet points 6 will all be addressed in the following webinar. I just put them here for overview's sake. I also put this Pantare thing there with this ancient Greek. I think the philosopher is Heraclit. And it says all flows. So all of what I tell you is to be taken with a certain grain of salt, because the technology is moving so quickly that the principles stay the same, but the models can change, and the way you deal with the models can change. So it's a constant effort to keep on top of it, which is our job, which is fine. So the first topic here was probability engine. So what does that mean? It's actually this is something that I explained in a previous webinar. So I just stole it to make my preparation easier. And I'll just explain very quickly. If you want to know more about it, go to the webpage and take a previous webinar. So how does actually an AI work? So you have a sentence. So AI has a huge amount of data. It has collected all the data that is freely available in the internet, and maybe even stuff that is not freely available in the internet. And all of this data is in there. And then out of this data, it tries to calculate the most probable answer out of a given probable word out of given previous words. That means, so I have the sentence, the cat chases. And then in this huge amount of data, probably the LLM finds 500 more sentences the cat chases. And in 5% of the cases, it chases a samurai, and 70% of the cases, it chases a mouse, 20 a squirrel, 5 a temple, and never the Fuji. So when it receives the cat chases, it will probably answer a mouse, because it's what, looking at its data, the most probable answer. But since we're in probability, it might also answer the squirrel. It will probably not answer the Fuji, but there's even a chance that it provides, it answers a samurai, which it might have seen in a, I don't know, manga movie or something. But Fuji doesn't work. So this actually leads to very interesting things, because first of all, you cannot really predict 100% the answer of a chatbot, which is actually fun because it makes it more human. If it always answers in the same way, then you have the very dissatisfying results of Siri and Alexa, for example. And actually, it's probably also the reason why these big models are not available on Siri and Alexa, because Apple and Amazon cannot really be sure what the answer actually will be. And then they run into the risk that they do stuff that Apple and Amazon don't want to be responsible for. And because, so basically using Siri or Alexa, you can see that, that even these big players have no way to 100% control the behavior of a bot, because it's just probability. For example, I tried to design an image of a pink elephant chasing a mouse. It was impossible to do that. The mouse was always chased by the elephant, because probably in the training data, there's not a single instance of an elephant chasing a mouse in the world. And so these are the limitations of AI. So what you don't tell it, it will not know and answer. Second thing, also a very important thing, but I talked about this a lot in the previous webinar too, is similarity search. So what is the most similar thing to, I don't know, a tram traveling through Europe by Mark Twain? And the most similar thing to this book is a previous edition of the book. And then comes the problem that the previous edition, because there was a really hardworking librarian, might be even has better metadata. So instead of recommending the most recent version of this book, it recommends the 15th edition, because if things with more metadata, it's more relevant. But of course, if you say I want a book in the style of, I don't know, Huckleberry Finn by Mark Twain, you don't want to have other editions of Huckleberry Finn. You want other books in that style. And this is something the AI just really has problems with, because it doesn't know that, you know, why another book, which is really more similar than any other book to a particular book, because it's just the other edition, should not be taken into account. And so actually we had to build a function that tells the AI, if you get an answer, don't answer with the titles that are exactly the same than the titles in question. So that's actually one of these things that you do. You don't adapt the LLM itself, but you kind of adapt the commands and functions that you build around the LLM in order to answer to your use cases. We also received the question about making a webinar on how to build your own AI. I think if you have a customer-facing product, this needs more intensity and time than you might imagine, because these are actually the edge cases you always have to deal with. Next issue, and this is one I'll show you. The thing is, AI, as I said before, only knows the things that it has been taught. And sometimes you have, for example, authors that don't feature in the training data of the AI. So for example, you have a guy called Mosolve. I made an image of a crazy scientist, and the works of this Mosolve have never been part of the training data. And for the AI, an AI doesn't know whether a word is a name or just a place or a mountain or a leg or something. An AI just takes this particular word and puts it into a context, and then out of the context, it develops its meaning. The problem is, if it doesn't know this word, it cannot have a context about it, because it never ever featured in its training, and then it cannot develop an answer out of that. So the problem that we had here was that actually you asked about this Mosolve. We know that books of this guy are in the list of our data. So as there are 2 books of this guy in the library, but the AI wasn't able to find it. Let me show you how that plays out. So we go here, we make a new conversation. Actually, I have to briefly go to the admin. By the way, for the people who really like this part of the presentation, we'll do some more of that in a later stage. So these are actually these are the famous prompts that you have seen in the red. There's a function actually that was really difficult to make the chat bot always answer in the language of the user. Okay, so this is actually our hybrid search. I deactivated it. I deactivated this as well just for security, and now I go to save. And now what happens? I hope, because AI is a probability engine, so actually every live presentation is always a bit of let's say a surprise. I say, do you have books about of Mozov? Andreas Mozov. Actually, no, I'm talking about Hans. So I am talking about Hans. Let's see what it does. First of all, it thinks. It thinks a lot. Okay, and you can see here, Hedi Schulz, Hans Moser. There's no Hans Mozov here. So because it never heard about Hans. Actually, this is the same. It's also a good thing because yesterday I made the same webinar. I made the same example, and I showed the same example. And the funny thing is that today it's so we by now, if it remembers our conversations, the AI, it should know by now. But that it makes the same mistake again shows that it doesn't learn from anything. It doesn't remember anything we have previously talked about. All right, so now let's see how we can solve this problem. So we go to our chatbot. Let's make sure it's not the live chatbot. Yes, it's that one. And then we actually do the hybrid search again. So search for entries. So this is actually the command that is behind this function. Search for entries that have a matching text to the given input. These is provided in addition. So this is actually a keyword search, and these keywords are provided in addition to the entry found by the similarity search. So this is basically a function that does hybrid search. All right, let's see whether that works. So we go to the website. We have a new conversation, and we ask the same thing. Do you have any works by Mozov? Actually, I thought about Hans. Now it's in thinking mode. So this is actually a good thing for context, because I say Hans, I don't say Hans Mozov in the second thing. So it has to deduct from the first question that in the second question, I'm talking about Hans Mozov. And here he is. So, and then it actually suggests other works by other authors, which are related to this, which actually were part of the first answer. So this is how it works. So of course you have the problem with the similarity search, that it doesn't find things that are not in the training data. But if you combine it with a keyword search, you still get the right results. So this is actually our daily work to kind of build around the shortcomings of AI to get great results. All right, let's go back to the webinar. Okay. Also, I really like this. It looks so real. Of course, it's only a prompt. It's about a know-it-all. It's also something I mentioned in a previous webinar. The AI wants to know all, and it will answer every question, no matter what, and no matter whether it really knows the answer or whether it just has to come up with the answer. These are these famous hallucinations. One word to the hallucinations. In our experience, and we are running the bot since June last year, hallucinations have never been a problem for the users. They always feature in the discussion with the librarians. So I wouldn't overestimate this issue. As soon as you're in a recommendation bot, I don't know if we build a bot for financial services, that might be different. But the way you solve it, by the way, is that you, of course, you prompt if you don't know something, answer that you don't know something and don't invent something. It's a good prompt. It's in our prompts, but it's, as we are in a probability engine, not 100% sure. What does work very well if you provide the bots with all the answers and actually provide links on the websites that answer the specific questions, for example, about opening hours. So you have to provide the bot with the data it is supposed to work with. If you don't, you run into the difficulty of having hallucinations once or twice. So this is how we do it. I'm not going to show it to you because we're running out of time. But so this is a screenshot from the prompts in the back end. And so typically 10 euros. And then, for example, this year is Mein Konto intern. This is the website where the answers for the accounts actually are. Next one, last really important one in this webinar. The thing is, how does it's actually one of these issues that regularly appear when people don't really understand the difference or are not aware of the difference between search and AI. So they just work really differently. So for example, the search is just a really precise and very specific person. And AI is just, it's a human. They just make sense out of things. And if they don't make sense, they, come up with stuff. So it's just really different things. The problem is that because it just tries to make sense of things, it doesn't always get the sense right. Let me give you an example. So this is, excuse me. So this is Mark 21, part of a Mark 21 file that we imported. And here you can see how we turn structured data into natural language data. So the content type is text, the media type is computer. And now we come to one thing. The two red ones on the top say it's an electronic resource and it's an online resource, which for everyone in question makes it clear that this is a digital. But in the last sentence, it says index term are Zeitschrift. Zeitschrift is a journal. And Zeitschrift is probably in the world out there, and 90% of the cases is used for a printed journal. So the LLM, you have to imagine the LLM being a person, and the only time it heard the term journal, it was in the context of German journals lying on a table, or journals delivered by the post. So it really thinks that a journal is something printed. And even though in this context, and it doesn't really know that the first two, electronic resource and online resource, kind of rule the type of the particular media in question, and it just doesn't know it because it's not trained on that. And so for the model not being a search engine but just being a person, this is a contradictory information. And so the answers to based on this data will not always be right. And so this is a very good example also of our everyday work. So for example, in the Berlin libraries, for some reason, a couple of years ago, they labeled in their internal database films as, what was it? E-film or something, for streaming films. Streaming is streaming, but for the library, it's e-film, and like electronic film. No model in the world knows that for the Berlin libraries, e-film is a streaming film. So we had to tell it, if that particular word appears, the user is talking about streaming. And so this is actually really the bits and pieces that you have put together in order to get meaningful answers out of the data you import and that you work with. All right, so that is that. So you can see there are a lot of constraints with AI so far, but you might get also an impression of how we work with these constraints and turn them into something meaningful. And but now I'm going to show you actually two things, because we don't want to talk only about the stuff that is difficult to solve, but we also want to talk about, fun stuff that you can do with it. So this is, for example, what you can do as a university, or actually in this case as a library. You can allow staff or students to play with AI, which I think the only way to really learn about AI is to work with it. And so this is what Berlin Libraries did for their staff. They made an AI, KI in German is AI, laboratory. And there people of the library can test with the different models. And also they can test the different models in relation with actually different prompts. And in the future, I think we're expanding that to how does a prompt react with the model or react with the context. So these are tools that can be used to teach AI, because actually the best thing is to work with it. So just to give you something to think about. Of course, as a university, you can also do things like Scopus AI by Elsevier, which is a very good thing to talk about content. But of course, since this is a publisher, you're limited to the content provided by Elsevier. And I think the other publishers are now really scrapping their stuff together to offer something like that, because otherwise they become really, really predominant in this landscape. But that would be actually interesting for us if you're in a university library and you want your library content to offer to your students through AI. That is something we haven't done, and we would be really interested to work with the university on doing. The second thing that we do, and I'm going to show that, and that actually would be really interesting if there are other libraries who have similar institutions around the corner to do something like that. I'm going to show you. This is a prototype we built together with the Metropolitan Museum in New York. So they're actually with a library, with the Watson Library of the Metropolitan Museum in New York. And their issue was to link the, I'm already in the browser, stay in the browser. And they had the issue that you have the collection data of the museum and the library data in the library, and they didn't really work well together with each other. And that actually is one of the core strengths of AI, that you can actually use any kind of data and put it together, maybe naturalize it a little bit and use it. And I'm showing you how that works. So actually, this is available. It's really a prototype, so we test that. It's available on Apple and on Android as well, but for showing things, it's just better to do in the browser. And we start a new thing. You know, the funny thing is here, you can also act as you're a child, and I say, I put in an ID, but of course you can also do a photo of the artwork, or you can do near field communication, or you can do a QR code, every other way to identify a work of art. And then, you know, the bot starts thinking. It's also so a sure thing, and it answers with, you know, a fish and a star. And, you know, it just talks like talking to a baby. So that is already fun. I'm not aware of any museum guide, or actually also in the library, you know, you have a children's section, and the bot might actually talk different about children's book than it talks about science books, or about, so you can actually also in your library bot, you could define different roles for a tourist, for a researcher, for a staff, for a child. So this is an idea actually we could also do for a library. So these are actually then the really new things. So actually I start a new chat, I take a scholar, and then actually I take the same artwork because I enjoy Japanese art. And so now, so this is again this Naefendel Kozuka. And you can see the text is already very different. It doesn't contain any smileys and stuff like that. And now comes the interesting part. I go show references, and these are books. These are books in the Watson Library. So what we did, so basically what you can do as you go through the collection, if you find something interesting, you just go upstairs in the Met and check out whether you can get the book on what you have just enjoyed. And of course, for the library and for the museum, it's great because they can follow the users' behaviors and what they're interested in and what they want to research. So this is one, I think this is a use case where for the first time, you know, so far what I find annoying is that AI is always talked about as a thing that makes things more efficient, which personally I think is totally boring, because I think I'm efficient enough. If I'm becoming more efficient, I probably really get crazy. But what it really does, and this is what I find fascinating, is that it allows new use cases like this one. So collaborations with institutions, collaborations with cultural institutions, where you can, you know, add an experience with, add up, for example, knowledge to an experience. So in the survey that we have attached to this webinar, we ask whether you would have interesting use cases in that sense. because this is what we really think is fun and is interesting to do. So back to the webinar. So I'm done more or less. The last thing. I know that for many this was maybe too technical, but for the ones it was not technical enough. We offer a workshop. So what I've done before, so checking the prompts, changing the prompts and seeing the results is something that is interesting for many. And so what I'm offering to you is that you can, the prompt sets we have written for the FEP are freely available on GitHub. So you see the link here in the slide. We're going to send the PowerPoint around later, so you can check out the link. So all the prompts of the FEP are in here on GitHub. So what you could do is you go to the FEP website, so the site of the Berlin Libraries. It speaks any language, so talk about it in the language of your choice, and then you test its behavior. You ask, for example, you do a similarity search, which is something very good to test the capabilities of a bot. For example, something in the style of is always something that RAG systems have a problem with, or other things. And then if you see a behavior that you don't really like or that you think is incorrect, think of a prompt that would solve this issue. And then on the 12th of March, we're going together into the backend. We'll take your suggestions on how to prompt this problem away, and then we'll test it. For people, if this sounds too complicated for you, I'm going to show you. So we have a problem. A student is looking for a biography of Hitler, because National Socialism is very prominent in our history lessons. So this is actually a very a case that could happen very easily. So now I go to the chat of we do a new conversation. I open a chat, and I say I would like to have a biography of Hitler. What happens? I'm sorry, I cannot. So it doesn't recommend a biography of Hitler because, and what is the reason for that? We go, oh no, this is not where we want to go. Sorry, I'm too quick. We go to admin. We go to the chatbots, we go to my chatbot. So these are the prompts. And now I'm going to find, and these are the commands we give to the bot. Do not recommend any works by Hitler or anything that could be harmful. Maintain a firm stance against National Socialism, which is, I think, a very important prompt to do. I mean, every country and every culture has things it, doesn't really want to discuss in public, and being held accountable for that. But in this case, it clearly had unwanted results because, of course, as a library, you want to provide students to learn about Hitler. Even Mein Kampf could be recommended if it's kind of in a commented version that puts everything into perspective. So what we need here is a prompt that actually provides these books that speak about this particular issue, but not kind of the propaganda that might also be in some hidden section in the library. So the task for the 12th of September would be that, if you encounter this particular issue or any other, you say, okay, delete this prompt altogether or formulate it in a way that this and that way, and then actually the biography of Hitler will be recommended. So this is the thing. So you can do whatever, and we'll just then try it live. And in the meantime, as I said, the best way to learn about AI is to play with it. Even better is to test it. So to have a test bot set up and feed it with your data and see what it can do. That's, of course, something that we do. And then you will learn. But the most important thing is to do it and actually to share it with others who want to do the same thing. So that's about it. Right on the mark, it's 12. But of course, I'm still here. And I open the chat if there are some questions. I'm running through it. So actually, you're always free to leave, but you're free to leave now. but I'll stay for 5 minutes and see if there are some questions that I might ask. Oh, from down under, good evening. That I like really. So Finland is great. What about training? They may need. Well, actually, the best. Somebody is asking. I think this is the down under. I don't think that digital natives know that by default. Actually, based on this webinar, go to the prompts of the FAP, which I are on GitHub. Look at it. You will notice that actually the prompts are in natural language. So you say things like "Don't use emojis" or "Don't recommend something by Hitler." So basically, you can really talk to the bot and say what it should and should not do. The only real issue is that the bot sometimes just ignores what you tell him to do or interprets it in another way, and this is when testing comes into play. Let me see. Are there any other questions in the chat? Which vector embedding are you using? We're using OpenAI. Is it Ada 2? No, Ada 2 was the one before. So we used the most recent one by OpenAI. We tested some others, but OpenAI for our use case seemed to be the best thing. And but frankly, we're not super happy with the embeddings. So I think they can be done better. We wanted to see whether Mistral is doing well because they, supposedly they're better with European languages. But we kind of do that every half a year, and the next test is due in I think May, and then we'll test other vector embeddings. All right. What is the cost of a chatbot if our library is associated with companies you work with? Showed in the presentation. So that first of all, there is a pricing on our webpage. So the easiest way is 180 euros per month. By the way, keep in mind that we also need from that, the tokens are included. So what's also included is what we pay in tokens to OpenAI. And then it depends. It depends on the size of the metadata of your libraries. Let's say if it's like, I don't know, 200,000, it's a very different story than it's like 3.5 million, because all these metadata needs to be processed. And also it depends very much on whether you want to you want to have access to the backend and create your own prompts, which is then something that we really have to talk about. But if you just want to have a bot to use your data, and if your library isn't too large, it's 180 euros per month. Clarivate's AI research assistant right now. So yeah, these research assistants are fascinating, I have to say, and try that. I'd be very happy if you give me feedback on how you find it and how they compare. All right. Anything else you have? Like, I answer everything, but otherwise, there are more questions coming. Okay. Have you worked with open access repositories? No, but we really want to. So I think because I mean, just give me a big background on open access. The thing is, what we see is, of course, you have Scopus AI and you have Clarivate and stuff like that, but they're all sitting on top of proprietary data. And I think the real fun of it, of course, would be to have everything, of course, that is legal and that is open access. So we would really, really like with open access. So if anybody's interested in trying open access with AI, we're up for it. All right. Thank you. Gracias. Merci. And hope take the survey and hope to see you at the next webinar. Bye. Bye. Bye.